Picture this for a moment. Earth, that little blue speck we call home, torn away from the solar system and thrown into the darkness of deep interstellar space. It's a pretty unsettling image, isn't it? But don't worry. Thankfully, it's highly unlikely to happen, though not impossible. Out there in interstellar space, there are probably millions of rogue planets, also known as galactic nomads or orphan planets. These planets roam interstellar space just like a spacecraft would, without a destination, shrouded in the darkness and in the silence of deep space. Currently, we've only found 70 of them, but that doesn't mean there aren't many more out there. Since they don't orbit a star, they don't reflect light, making them much trickier to detect. Luckily, Earth is securely tethered to its star, the Sun, through an elliptical orbit caused by the gravitational pull of the Sun. This force that binds us to the solar system is directly related to mass, and considering that the Sun contains 99.86% of the mass of the entire solar system, we can say that we're currently very, very stable around it, and therefore our orbit is well established and constant. To move Earth away from the Sun, something causing instability is required. We could face two different scenarios. A star, which by passing close to the Sun drags us out of the solar system, or a very massive object that enters the solar system like a rogue planet. In the first case, as the star approaches the Sun, it would encounter the Oort cloud first, a sphere of asteroids surrounding our solar system at a distance of 150 billion kilometers. This would lead to a bombardment of asteroids in the inner solar system, with thousands of asteroids heading towards the inner planets, including Earth. We know that a similar situation has occurred in the past and will happen again in the future. Gliese 710, a red dwarf with half the mass of the Sun, is currently heading towards the solar system, and in about 1 million years will cause major disruptions within the Oort cloud. This shouldn't alter Earth's orbit because fortunately the star won't actually enter the solar system, but will pass by it, skimming it. So for now, crisis averted. But the probability of an actual star capable of throwing us into space in the next 5 billion years has already been estimated, 1 in 100,000. It's not very high, but it's still 6 times more likely than winning the lottery. In the case where it's another planet that throws us out of the solar system, things get even more interesting. First of all, because not being able to identify most of the rogue planets, we can't make long-term predictions, nor can we calculate a probability accurately. There could be a planet out there that is aiming at the solar system much, much closer than the star Gliese 710, which will arrive in 1 million years, but we can't see it. If this planet were heading towards the center of the solar system and was massive enough, well, we might have some trouble. In fact, the strongest instabilities occur when an object passes through another orbit, crossing it. So if this object passed, for example, at a distance between Mars and Earth, Mars would be at much greater risk than Earth of being expelled from the solar system. But if this object passed at a distance less than that of Earth's Sun, for example, between Venus and Earth, at that point it would cross Earth's orbit, and Earth would experience greater disturbances due to this passage, which could lead it to become a true rogue planet, launched out of the solar system. Surely this wouldn't be a great day on Earth, but the days to follow would be even worse. In fact, in just 3 months we would surpass Mars. The average temperature would already be almost 50 degrees below zero. Solar radiation would be only 44% of what we have today. Unable to perform photosynthesis anymore due to extreme temperatures, all plant life would die. Earth would become a gigantic ice ball with the characteristic blue-green of its surface turning into the pale gray-white of death. Once reaching Jupiter, the temperature would be around minus 150 degrees. Due to Jupiter's immense gravitational field, there would be a high probability of becoming one of its many moons. To be precise, we would be the 80th moon. Without solar energy evaporating water, clouds would no longer form. The temperature would be so low that all the water vapor in the air would condense to the ground, and the water cycle would stop completely. In a very short time, 99% of species would become extinct. Only some bacteria and organisms living in the depths of the sea would survive. warmed by the heat of the Earth's core. A situation similar to that on Europa, one of Jupiter's moons, would arise. Thick layers of ice would cover our oceans, leaving only the deepest waters liquid. And in case any humans were still alive, perhaps in some bunker or something similar, if they wanted to take a walk on the icy surface, they would have to remember to wear an oxygen mask. In fact, Earth would have lost most of its atmosphere due to gravitational interactions with other planets, especially larger ones like Jupiter, with Earth's gravity no longer able to retain atmospheric gases, so the atmosphere would become much thinner. Continuing to move away, with the sun getting smaller and smaller, we would leave the solar system behind after passing the heliopause, a zone about 12 billion kilometers from the sun, considered the boundary of the solar system. Before this frontier, space is dominated by energetic particles emitted by the sun, the solar wind, composed mainly of electrons and protons. Beyond the heliopause is interstellar space, the region where cosmic radiation dominates. Earth, with an extremely thin or completely absent atmosphere, would thus be exposed to cosmic radiation bombardment. Life on the surface and near it would become impossible, and the only survivors would be microbes and microscopic organisms near hydrothermal vents on the ocean floor. This would remain of Earth, a frozen, solitary planet traveling in the silence of deep space. And maybe this is the story hidden behind one of the 70 rogue planets we've seen in the sky.